The first type of angle relationship that we're going to talk about are called vertical angles. All right? In vertical angles, the two ways that I would describe them is that they are opposite and congruent. So congruent's fancy math word for the same measure. So if vertical angles, it's a pair of angles. If one's 30 degrees, the other one's 30 degrees. If one's 120 degrees, the other one's 120 degrees. All right? And so from our little picture off to the side, there's a couple pairs of vertical angles I'm going to show you. There's angle AEB and angle DEF. Those are vertical angles. So let me point out where those are. AEB and DEF are vertical. Do you see how they're opposite each other? Incongruent? So any two lines that intersect each other, they'll always make two pairs of vertical lines. The other pair of vertical lines, and it's a little harder to see, is angle BED and angle AEF. So let me point those ones out for you. We got BED and angle AEF. So these two obtuse angles are vertical, and these two acute angles are vertical. And so if I gave you angle measures, you just know that vertical angles are congruent. They have the same angle measures. Cool. We remember that from last year now? Yeah. I remembered vertical when I was a kid because I imagine like there's no gravity or something, and then a vertical is someone that jumps. So if I was like at an angle and I jumped straight across to the other angle, it kind of helped me with the opposites somehow. That's kind of what I remember doing. All right, next angle we're going to talk about is called adjacent angles. And adjacent angles are next to each other. Is each other one word or two words? That's what I thought. Usually I just like put a little gap there, but not enough to like where it'd be like, oh, maybe it is, maybe it isn't. That's a little hack you can use in your English class, all right?
Well, nice for typing.
So usually I write it like this. Something like that. Like it's like, is it together? Is it not together?
People just assume that you're right.
Exactly. They're next to each other, and then they're always going to share a ray. They share a ray. So a ray is one of the vertexes to forever. So there's a bunch of vertical angles in this image to the right. I'm just going to point out a couple. Let's look at, I'm going to say angle AEB and angle BEC. Those are vertical, so I'll point those out, AEB, BEC. Notice they're next to each other. Okay? They share this ray, EB. Another example might be, let's get a little weird with this. Okay? BED and angle DEF. So I'll point out those. Those are also, there's a bunch on here. But BED and DEF, they share this ray, ED. So they're just next to each other. So when you're older like me and you want to sound really smart and just saying like it's next to this, you say it's adjacent to this. In the English language, it means next to, adjacent to. It just sounds pretty cool. Make you sound a little fancy. You throw your monocle up while you're saying it, okay? All right? Your top hat. That just sounded like Monopoly. Just trying to sound smart, you know? Someone's like, "Where's the student the student activity center?" I'd be like, "It's adjacent to the luncheon." Something real smart that way. All right. It is. It shares a wall with it. It's right next to it. Okay. Next, we have complementary. Some people think these are the nicest ones. That's a bad joke. Complementary angles say stuff like, "Hey, nice hairdo." All right. So complementary angles, they have a sum of 90 degrees. Now, they could be adjacent. They don't have to be, right? I could have a 30-degree angle up in this classroom, And over there in Miss McCaffrey's classroom, we have a 60-degree angle, and they're still complementary. 30 plus 60 is 90. So any two angles that have a sum of 90 are complementary. However, lots of times it's pretty fun. Like in our image here, angle AEB and angle BEC, those are complementary. Do you see how those two together make 90 degrees? You guys see that? They're also adjacent. They share a ray, but they're also complementary because they have a sum of 90. Those are the only complementary angles on... No, I lied. There's another pair of complementary angles, and it's pretty cool. So because AEB and DEF are vertical and congruent, that means angle DEF and angle BEC are also complementary. Let me explain that. So I think most of us can see that AEB and BEC make 90 degrees right here. You guys see that? So, but these two angles are vertical, which means they're the same, which means this angle and this angle also have to make 90 degrees. Right? If these two are the same, if these two make 90, these two also make 90. But they're not adjacent. That's cool. Huh? So any two angles that equal 90, a sum of 90, they're complementary. Okay. Then, really similar complementary angles are supplementary angles. Okay, and they have a sum of 180 degrees. Now, the way I remember which one's which, complementary starts with C, supplementary starts with S. C comes earlier in the alphabet, it has the smaller angle measure 90. That's how supplementary comes later, it has the larger angle measure 180. Yeah, Jack.
Can adjacent angles go over 90 degrees or that?
Yeah, any two angles that share a ray. So it can be two angles that make more than 180 even, right? Yeah. Lauren. Because it's all about relationships. Get it? No? I watched it once for 5 minutes, got way dumber. So I stopped that real quick. Okay. Anyway. Supplementary angles. So let's look for some supplementary angles here. Let's go. I've been rocking this angle AEB a lot today. AEB and angle BED. You guys seeing that, how those make 180? They make this, and you'll hear me reference the AEB and BED. Here's that obtuse angle BED. Here's that acute angle AEB. And they make this is called a straight angle. A straight line is called a straight angle. And how many degrees in the straight line? 180. Like if you go from here to A, it's halfway around a circle, right? Half of a circle is 180. So straight angle is 180. Also, if this is 90, what does 90 and 90 make? 180, right? So there's some other supplementary angles. Another fun one might be angle BEC and angle CEF. You guys seeing that one? BEC and CEF. Any two angles that make 180. Now, these happen to be adjacent as well. They don't have to be adjacent. I could have a 30 angle up in this class and a 150 degree angle down in Mr. Miller's class, and they're still supplementary. Okay? Now, if one of those up in Miss Wilford's class, I don't know, because I heard that's a different dimension. So I don't know if things get weird in there or what. Okay? I walked in there once. I walked out. It was 2 years later. I thought I was in there for 2 seconds. It's just what I heard. I read it somewhere. Anybody have Miss Wilford last year? No? All right. So that's supplementary angles. One more thing, and it's kind of related. And it's... I wish I could do effects on these videos. The Triangle Sum Theorem. I need to get a kid that's into editing videos and make these things sweet, like explosions and stuff. Anyway, here's how I like to prove the Triangle Sum Theorem to you. There's another cool way with parallel lines, but we're not there yet. Here's a square or a rectangle. How many degrees are up in there? 180. If I go corner to corner, I got two triangles. How much in each triangle?
90.
I screwed that up. It's not 180. It's 360. So I was on that triangle train. I was on the triangle train. So each triangle is 180. All right? So the Triangle Sum Theorem means 3 angles of any triangle have a sum of 180. Doesn't matter which triangle you're rocking. It's always 180. There's another cool way you can prove it with parallel lines and a transversal. Yeah, that's going to be too much. Just someday you'll see an image like this, and I'll teach you something cool about it. Okay? If you ever forget what the triangle is, start with a rectangle or square. You know that's 360 because 90 degrees 4 times. Right? Cut that in half to get a triangle. It's 180. That's another easy way to remember it. Cool. I need one person per table to go grab the homework. We're going to look at 4 problems together on the homework.
All right, thank you.
I'm going to talk you through my thought process when I see something like this, because this looks different than our notes, but it's the same understanding of the angle. So, I look at these 2 angles, and what do I know? What type of angles are they? Who can raise your hands and tell me? James.
Adjacent angles.
They are adjacent. What else? Yeah. Complementary. I know that because this little symbol right here, that right angle symbol, tells us that those 2 angles together make 90 degrees. So if they're complementary, here's what I know. I know angle 2x plus 1 and angle 33 have to have a sum of 90. Look what we got, guys. We've got ourselves an equation, and we can math this thing. So from here, we're going to combine like terms. We're going to isolate the variable by putting Spencer.
Why do people keep putting me in closets? I'm sorry.
Okay. And then x is 23 degrees. Now, here's the dealio. In this case, it's asking what is x. That's it. But you could also find this angle measure by substituting 23 in for x and getting my 47. And you might want to do that to check your answer, because what should be true about these 2 angle measures? They should add up to 90. So something's wrong.
It's 28. Yeah, it's 28.
What'd I do?
You made it fit 46 instead of 50.
Dang. So, well, no, here's the deal. Did you see how we didn't add up to 90?
We just had paparazzi.
I mean, I didn't do that on purpose, but it worked out nice showing you that the check told me I was wrong.
I think that they just didn't care enough to actually think about how their problem is.
So divide by 2, and I get x is 28 degrees.
I was so confused.
So now let's check it. 56 plus 1 is 57. 57, 33, does that make 90? All right, we're good. That's cool, man. I made a little mistake. When we checked it, it didn't work out. We fixed it, checked it, it works. That's why you check your work, guys. All right, let's look at another one. So I'm checking this out. What do I know about this? So that's what I'm always going to start with, what do I know? There's a right angle right here. Yeah? So if it's a triangle, it has to equal how many degrees? So there's a couple different equations that I could get you. If you use the Triangle Sum Theorem, you might say the right angle plus 25 degrees plus 3x plus 11 equals 180, right? But you also might know I've got 90 accounted for already, so how many degrees are left? 90. So I would also take 3x plus 11 plus 25 has to equal 90, because that's how many degrees would be left. I would take either one. You're going to get the same answer either way. So when you do the algebra, you get 3x plus 36 equals 90. So 3x equals 40, something not right again. 54, there we go. So x is 18 degrees. And to check it, 3 times 18 plus 11, 30, 40, 54 plus 11 is 65. 60, 70, 80, 90. It worked. So x has to equal 18 degrees in this case. But do you guys see that I'm not starting with any of like the computation? I'm starting with understanding. Yeah. Start with conceptual understanding versus what steps do I do. Whoopsie. All right, on this one, what kind of angles do I have?
Vertical.
Vertical. What's true about vertical angles? Yeah, so 5x plus 12 has to equal 6x minus 10. And then I'm going to fly through the algebra because you guys took an equations quiz already. You should be pretty good to go with your equations, I think. If not, you can see my academic help. We can work on it a little further. So x is 22 degrees. When I substitute it in, what should be true about the two values? They should be the same unless I made another oopsie. Okay? So I got 120, 132 minus 10 for 122. Here I got 110 plus 12 for 122. All right. I got a couple of obtuse angles. How about this? A little extra. You know me. I like to be extra. Is that good? If someone says I like to be extra, is that good? I've heard someone say it before. What does that mean? It's not naughty, is it? Okay, that's good. All right. Anyway, that red angle right there. Can anybody tell me what that measurement is of that red angle? Spencer, what do you think?
Never mind.
Anybody have an idea? Adam.
Oh, it's the same as J.
Well, it's the same as J, but I don't know what J is.
Oh.
But there is enough information to know this angle.
You 180 minus.
Ooh, I'm hearing some stuff. Hearing some stuff.
Wait, I know this.
Spencer.
It's the same thing as GJH and FJI. Because it's like a perfect
FJI.
square. Because it's a perfect square.
Not F is FJI.
The angles have to get 368.
It's 58. And here's the dealio. That angle and this angle that I'm about to highlight make a straight angle or 180 degrees. These two angles are supplementary. So once I knew 122, 180 minus 122 leaves me with that 58. So that's cool. If you can know one angle with two intersecting lines, you know all four angles actually. It's pretty cool.
It looks like those like green and red like.
Last one. What do I know is true about these two angles? They're supplementary because they make that straight angle, which means 45 plus 3x needs to equal 180.
Aren't they perpendicular?
They are not perpendicular. Perpendicular angles intersect each other at right angles.
Oh.
Wait, so the supplementary angle.
So x is 45. What's 3 times 45? 120 plus 15, 135. And 135 and 45 doesn't make 180? Yeah, cash money. We did it.
Wait, so the supplementary angle of a circle's middle line is the diagonal, right?
I couldn't exactly follow what you were trying to say, but maybe. Who can tell me how many degrees K and M is? K and M.
180.
180. It's a straight angle, right?
First.
Cool. All right, guys. Let's get after it.